Hi, if you create a Spritesheet based animation, you probably do something like that. Create a game object with a sprite renderer, add Animator, add Animator controller, and add an animation with some keyframes, in which you just change a sprite and that's it. If it's all about you and your project is going to have many animated objects like this one, you are going to lose a lot of precious frames per second there. My name is Pawel, I make games, and I'm gonna show you the difference between using an easy but slow animator and something that you can write in basically no time or just download from the description below. This script has something called base animation, and it is just a scriptable object which stores an information about frames of gap between animation frames. There is 20 just like in the animator, we start from 0 and after 20 frames there is another keyframe. And an array of sprites to loop. Now we need to make sure that those animations are the same. I'm gonna select my spawner, which spawns 20 rows of those prefabs, duplicate it, and in the second one, select the spawner with sprite animator object. Change the rows to 1, and do the same in the first spawner, but this time it's animator object. Okay, we have 2 duplicates of a row. And as you zoom in the scene view, select a container with every copy of a given animation, and then move it a little bit to the left. Okay, it's in front of it, so let's move it to the right. Look at those hands. The difference in wait time between animation frames is slightly different, so sometimes those frames move away from each other, but basically it's the same animation. Exit the play mode. Now we don't need this duplicate, so let's remove it and go back with the settings of the original one. Now we're gonna use a tool which is under Window, Analysis, Profiler. In the Profiler tab we have a graph which shows us a time needed to render a frame of our game, and much more. The most important ones are CPU usage, and below that should be GPU usage, which is not needed in a 2D game. If you don't see the GPU usage, you can enable it in this menu. Okay, let's go back on top, and let's talk about this table. Here we have the names of things that need our CPU time to render frame. We can expand them. And on the right we have the time that CPU needs to do what it's told to do. It's handy to click on this button to sort them by time and have the most expensive part on top. If we disable a spawner game object and play the game just like that, we can see how much time do we need to render the game with the main camera only. Okay, we can use left mouse button to stop the game and see that we need 1.8 milliseconds to render one frame. We get 1 or 2 spikes, but it's Unity's thing and we can't do much about it. Just remember that this is editor loop. It's time for the first test. Enter the play mode and you can see the performance of 1800 game objects which use Animator. Click somewhere over there and the game is stopped and we can have a look. The biggest part of this graph is this blue area, which means Animator, as you can see on the left. The most expensive part of this frame is Director Update Animation Begin, which is from Animator. By the way, if you would like to see more data in this table, enable Deep Profile. We don't need it for this comparison, but maybe you will find it useful somewhere else. The other thing what is worth to check is your Spritesheet. I hope you know that you need to use one image with as many sprites as you can fit there and then slice it in the sprites editor, instead of using one image per one sprite. The second option hurts your performance. To help out our animator, we can change its update mode from normal to animate physics. Now the animator matches with our physics events. As you can see, we have many little spikes over there, but their value is the same as the regular value of our previous solution. And the area outside spikes is not so bad, I must admit. As we open stats over there and unpause the game, we can see that our average frame rate is now 160. That's not bad. Let's compare it with the previous solution. And you can see that the previous one was about 70. Compared to what we can achieve by using a custom animator, it's not a big gain though. Let's have a look on it. We have a animation data, which is just a scriptable object. There we have some basic informations about the animation, so let's leave it as this and go back to the sprite animator. There at the beginning we play an animation with our base animation. We just grab it and start a new coroutine. In the coroutine we have something to protect ourselves and this big while loop. Inside we basically change the sprite renderer sprite and wait for the next change. The wait time is based on frames of gap in the animation data. Enable the second component of the spawner and disable the first one. Those are the same scripts, so everything is fine and we are ready to test the second solution. Now we get something around 500 FPS. I think that's impressive. Okay, let's have a look on a profiler. And here we have some data. On average, we need 3 milliseconds to update the frame of the game. And sometimes we have spikes with blue areas. Those are the frames in which we update our animation. Don't confuse it with this spike. This one is from Unity. Let's have a look on it. We have an editor loop which takes most of this CPU time. And in this blue one we have player loop as the most expensive part. Here we have something called sprite animator, play animation, coroutine, move next. Its parent is coroutine delayed calls. And its parent is update script run delayed dynamic frame rate. This one takes in total 6.85 milliseconds out of 8.91. And as you can see, there is play animation coroutine, which is the same name as this function. We have this wait for seconds, which is the reason why we have this delay things in our profiler. It's also worth to note that there is 1800 calls in this type of action. Those are our objects that are animated in this frame. But if we move outside of the spike, we can see that there is nothing like that. So if you break the spike into many pieces, for example spawn those objects frame by frame, one row in every frame, there will be more of them, but they will be smaller, so the overall experience will be better. That's the time when we need to use this yield return new wait for seconds in our spawner. Make sure that you spawn sprite animator objects. And as we look at the profiler, we can see that our big spikes are gone. Now we are left with those Unity's spikes. You can see that the editor loop is bigger than the player loop. Oh, and there is one tiny spike, and the player loop is only 3 milliseconds. If we expand it, we can see that there are 270 calls, so only 3 out of 20 rows are updated in this frame. Now exit the play mode and compare it with the animator solution. This is the same script, so we will also spawn those rows one by one. Let's see. We've achieved nothing this time. We still have around 15 milliseconds to render one frame. And as you remember from the beginning of this video, that's the same value as we got at the beginning. The animator simply works in a different way. Okay, but let's check out what will happen if we change this update mode from normal to animate physics. Maybe now those tiny spikes will overlap. And again, the animator doesn't react to our spawning improvement. Okay, but for now I've been showing you only an animation. It's not the game, so let's add a motion to those prefabs. This script just moves the game object to a target, and if it's close to a target, it finds a new one. Let's have a look on sprite animator objects first. With this new feature, we get around 200 FPS. The objects are moving, and as they reach the target, they find a new one and go to it. Now exit the play mode and choose the second solution, the solution with animator objects. We get only 70 frames per second, so the difference is pretty big. If you feel like this tool will be useful in your game, feel free to download it from the description, it's totally free. And as a creator of it, I also feel obligated to tell you something more about it. All of that works only because we use yield_new instead of waiting as many frames of gap in data. Okay, but let's see what happens if we don't use that. And now instead of 200 we get only 140. To see the last thing, we need to remove this wait for seconds in the spawner. We can see those spikes again. And in this graph we can see 1, 2, 3, 4, 5, 6, 7 spikes. So let's see what happens if we change its animation frames of gap. Let's say from 20 to 5. Now the gap is way smaller. The animation is way faster, and if we go to Profiler, we can see that we have many more spikes. Those spikes are as big as usual, but there is more of them because we have smaller frames of gap. So in a given amount of time we get more spikes because of that. More updates, more spikes. So for instance, if we go with something crazy like 1 frame of gap, we'll have something similar to Animator's solution. That's worth to keep in mind. Another thing is that you may have heard that something like GPU instancing may help you a lot with optimization. Okay, so I've created a new material, sprite default, and checked this option. Now select those objects and use the new material there instead of sprite default. As you can see, we are stuck at something around 200 FPS. GPU instancing is more important if you used 3D shapes, not 2D sprites. I hope this video is useful for you, have a good day and see you soon!